Inverse trigonometric functions. Few facts about inverse functions. F inverse of f of x will equal x for every x in the domain of f. Likewise, f of f inverse of x will equal x for every x in the domain of f. The domain of f is equal to the range of f inverse, and the range of f equals the domain of f inverse. If a function y equals f of x has an inverse function, the implicit equation of the inverse function is x equals f of y. If we can solve this equation for y, we obtain the explicit form y equals f inverse of x. In order for a function to have an inverse function, it must pass a horizontal line test, where it crosses the original function only once. Here you see y equals sine x, and here you see that it fails a horizontal line test. So y equals sine x is not a one-to-one function over its entire domain, so it's not does not have an inverse function over that. But if we redefine y equals sine x on a carefully chosen domain, the new function can be specified one-to-one and therefore has an inverse function. So if we define y equals sine x to have the domain from negative pi over 2 to pi over 2 and range from negative 1 to 1, it is a one-to-one function. And there you see the graph where it's a one-to-one function, therefore it has an inverse. The inverse will have the domain and range switched around. And there you see the graph of y equals sine inverse of x. And the range of the unit circle, our answers are going to range from negative pi over 2 to pi over 2 because we're only in the first and fourth quadrant for those values. So, example 1, evaluate sine inverse of negative 1/2. Well, if I let theta equal sine inverse of negative 1/2, we now have an equation theta equals sine inverse of negative 1/2. To remember that f of f inverse of x will undo it, so let's just take the sine of both sides of this equation. So I now get sine theta equals sine of sine inverse of negative 1/2. Well, we know that the sine of sine inverse is just negative 1/2. So sine theta equals negative 1/2. Well, sine theta equals 1/2 when it is a 30-degree reference angle. And since we're in the fourth quadrant, we have a 30-degree reference angle in the fourth quadrant because it can't be in the first because it's positive there. So there's your reference angle. And since we're dealing with radians, we'll go with pi over 6. Theta equals negative pi over 6. Okay, example 2, evaluate sine inverse of 1. Well, again, let's just let theta equal sine inverse of 1. We can take the sine of both sides, and you're going to end up with sine theta is equal to 1. If you look at this chart of values, sine theta is equal to 1 at 90 degrees, or pi over 2. So theta is equal to pi over 2. So when we're doing questions like this, do we need to write sine of both sides? No, you can skip a step, which we'll start doing in example 3. Alright, first of all, we're going to define y equals cos of x to have the domain from 0 to pi and a range from negative 1 to 1 to make it a one-to-one function. There you see it. So then our inverse function, y equals cos inverse of x, can also be written as arc cos of x. We'll have the domain negative 1 to 1 and a range from 0 to pi. And it is an inverse of y equals cos x. There you see it there. All right. In the range, now we're going to be dealing with answers in quadrants 1 and 2. We're going from 0 to pi, that's why. So we're going to evaluate the cos inverse of cos of 4 pi over 3. Well, first of all, we can evaluate cos of 4 pi over 3. You know, that's a reference angle of pi over 3 in the third quadrant, and cos is negative in the third quadrant, and pi over 3 would be, cos of pi over 3 is 1/2. So what we have here is cos inverse of negative 1/2. So now what we can do is we could take the cos of both sides, and it's just going to eliminate the cos inverse. So we're just going to skip the step, and we're going to go to cos theta is equal to negative 1/2. And cos theta is equal to negative in quadrant 2, because remember, for cosine inverse we're in quadrants 1 or 2. So our reference angle is 60 degrees in quadrant 2, and that's going to be 2 pi over 3. Now we're going to deal with tan x and its inverse. We're going to limit the domain to negative pi over 2 to pi over 2. A little bit different than sine in terms of sine was negative pi over 2 less than or equal to x, less than or equal to pi over 2. This is just less than. And the reason being is tan is undefined at odd multiples of pi over 2. There's vertical asymptotes. All right, so here is a graph of y equals tan x. And since our domain is negative pi over 2 to positive pi over 2, that's what our range will be for tan inverse. And the range, or the domain, will be all real numbers in this case. Okay, so there's what your graph will look like. And now we're dealing with, again, quadrants 1 and 4, but we have open circles at pi over 2 and at pi. So we're going to evaluate tan inverse of negative 1. Well, if I let theta equal tan inverse of negative 1, I'm going to take the tan of both sides. So I'll get tan theta is equal to negative 1. Reference angle is 45 degrees, and we're in the fourth quadrant because it's negative. So that's just going to end up being negative pi over 4. All right, other inverse functions. Cosecant inverse x will equal sine inverse 1 over x. Secant inverse x will equal cos inverse 1 over x. And cotangent inverse x equals tan inverse 1 over x. Example 5. Find an algebraic expression for cos of 2 tan inverse x. So we're going to let theta equal tan inverse x. And so tan theta will equal x. If we just take the tan of both sides, we get tan theta equals x. And tan theta equals x is the same thing as tan theta equals x over 1, right? And if you recall, tan represents opposite over adjacent. So if we draw a little right triangle here, and put theta as one of your angles, we're going to have x on the opposite side and 1 on the adjacent side. And the hypotenuse will be x squared, square root of x squared plus 1. Remember, it's the sum of their squares, the square root of the sum of the squares. All right. So we have cos 2 tan inverse x Well, because we let tan inverse x equal theta is equal to cos 2 theta. Double angle identities. I'm sure you remember these fondly. Cos 2 theta is equal to cos squared theta subtract sine squared theta, or 2 cos squared theta subtract 1, or 1 subtract sine squared theta. Well, I think we're just going to stick with cos squared theta subtract sine squared theta. So we're going to rewrite the right-hand side like that. All right? Now, what we can do is we can realize, well, what is cos squared theta and sine squared theta? Well, how did we get these? Well, remember, cos theta is adjacent over hypotenuse. Okay, so cos squared theta is going to be adjacent over hypotenuse squared. So it's going to be 1 over the square root of x squared plus 1 all squared. Subtract sine squared theta. Well, sine theta is opposite over hypotenuse all squared. So it's going to be x over x square root of x squared plus 1 all squared. And if we simplify these, well, we're just going to get 1 over x squared plus 1, subtract x squared over x squared plus 1. And if we combine them, we get 1 subtract x squared over x squared plus 1, and that is it. That is our algebraic expression for cos 2 tan inverse x.